What if I was to say to you that one of the most extreme cars in the world, a car claimed to be faster than a Formula One car, came not from Italy or Germany or the UK, but from New Zealand? And no, that's not an AI backdrop. This is the Rodin FZero. Prepare to have your mind blown. Now, just in case you think you're looking at vaporware, here's a quick bit of background on Rodin. It's got previous, having bought the T125 project from Lotus and re-engineered it as the FZ. At its premises on South Island, it not only has its own racetrack and fully equipped pit garages, but a state-of-the-art production facility filled with 3D printers, a foundry and 5-axis milling machines. The investment here to build the FZero is colossal. It also recently bought the super successful Carlin Motorsport outfit that's competed in everything from F2 to Indy Lights. The man behind all of this is entrepreneur David Dicker. So David, where did the idea for this car come from?
I always wanted to build a car quicker than an F1, and obviously as time has gone on, that has become, more and more possible. Like back in the 70s and 80s, it wasn't possible in the same way because the cars were unrestricted and that was the quickest car anyone could make, but it's different now. So that was the idea.
So literally build your own F1 car, if you like.
Just to prove, I guess, that you didn't have to spend the enormous amounts of money they spend to go fast.
Yeah.
Obviously this car's costs money. We spent a fair bit of money on it, but nothing like what the F1 guys spent.
Yeah. So where did you start? What was your first port call? Were you doing the chassis, the aero, the engine? Where did you start?
Well, I started with the basic concept for the car. Obviously, you're going to use fenders because you're not going to have the tyres out in the air if you can possibly avoid it. And you're going to use a canopy for the same reason. And then it just sort of draws from there. I mean, I can't draw and any of that pencil and paper stuff. So I'm a computer guy from, way back. So it's all been done on CAD. But you start on the CAD and you just, you just draw lines and you pull around and you just sort of do stuff and
So, right, can we go through it a bit and just
sure.
talk me around it? So where do we start with, because the proportion of some of the sizes you've got for like the front wing and everything, they're huge. They're absolutely huge. So how much downforce are you developing?
I think the front wing can make 1,800 kilograms.
The front wing can make 1,800 kilos.
We do all our testing at 300k, but I think that was the sort of number that we could get out of it. It's a lot.
Wow, it's enormous.
Yeah.
So if you've got 1,800 kilos on the front axle, how much have you got on the rear?
Well, this car generates probably a bit over 4,000 kilograms of downforce.
At 186 miles an hour, 300 Ks.
We're going to do I've pretty much finished the design for a Mark II car that's learnt from this car. We're going to run a lower downforce there. We're going to probably run about 3,000 kilograms.
Right.
Because the 4,000 just gets a bit high. Issues with the tyres and all the other stuff.
And you've done everything in-house? So the aero's been done in-house?
I've done all the aero. We will use outside consultant guys to just sort of correlate it and make sure that no huge idiotic mistakes were made, but yeah, basically.
Yeah. And are those guys all F1 engineers who have...
They're guys that have worked in F1.
So if we come back down the side, these look suspiciously like Formula One style wheels as well.
Yeah, well, Oz made these wheels for us and they're basically the same as the F1 wheel. It's a forged magnesium wheel and all the details have been done. I think these wheels are 8 kilograms on the front and 8 or 9 at the back, and this is basically as good a wheel as you can get.
And these fenders, I understand, are they not finished yet? You've got a bit of work to do with these.
Well, it didn't quite. They're obviously sitting too high and didn't quite come out right. I mean, it's fine on a proto and that, but on the version 2 car, we bring these down pretty much as close as we can possibly get them, just to reduce the frontal area.
So you've got full carbon suspension. It's all inboard, obviously, and everything's just sort of tidied up very neatly. So you want clean air, I suppose, coming as far down the car as you can.
Yeah, well, the big advantage is that you can send most of it down there. Obviously, on the F1 cars, they just got an enormous block there, or on a sports car, you've got an enormous block there, and that's just going to kill you.
Yeah.
We could put the radiators in the fenders, so the radiators are in on an angle, and we just draw through here, and we just fire out the back. So
because that's exactly what I was wondering. I was trying to work out where you were doing your cooling, because there's going to be a lot of heat being generated, and so the radiators are all out in the flanks, and then the cooling pipes are running from in underneath. Right, but you've got this is fascinating to me. You've got the 5 exhaust pipes. So you've got a V10 in there, which we'll talk about in a second. But the 5 exhaust pipes run out into the flank.
Yeah, well, the turbos are in there. So again, we got to get it out of the the airstream.
Yeah. So you've got turbo on either side, so twin turbo engine, and tell me about the engine. In fact, tell you what, before you do that, can we take the engine cover off and have a look? Because I think we can have a look under there.
Yeah, sure, go ahead.
Just look at how tight the packaging is under the carbon cover. Dicker is rightly proud of that, especially having the intercoolers mounted directly on top of the trumpets, reducing the intake lengths. The engine is a custom-built 4-litre V10 done entirely to Rodin's design. They had originally considered using a Judd V10, but eventually the plan is to build road cars, and that engine, with its port injection system, would never pass emissions regulations. The first 2 engines were built by a British specialist, but in its production facility here, Rodin has all the tools necessary to create its own engines from the ground up. They even have a foundry for on-site castings. They are one of the few companies in the world that can do everything from casting engine blocks to test driving cars on the same site.
You can't build cars without a test track. The test track's really got to come first.
Yeah.
It's just, you need to pound around to get them working.
I completely agree, but I think 95% of the world's car companies haven't got the facilities in the way that you have. Fiorano is probably the closest comparison you've got here.
Yeah, well, I've been to the factory in Italy, on numerous occasions, and you see the way that they do it, and obviously Ferrari's very successful, and
But you've got more power than a Ferrari in here, haven't you?
This engine made 1,013 horsepower at 11 psi at about 9.6.
Yeah. So, and that's not production ready yet.
No, that was really just a run up.
And you're looking at, what do you think?
Well, we run the engine to 10,000 RPM.
Yeah.
And we'll run 1.5 atmospheres, so that's 21, 22 psi.
Yeah.
So that should get us to 1,500 or 1,600 horsepower, which in what should still be a reliable package.
Yeah.
And that'll be the aim.
Yeah. And what are we talking for weight?
This car is way too heavy, and it's embarrassing to even mention the number, so I'm not going to mention it. But
what are you aiming for?
Our aim is to build a car at the same weight as the current F1. The F1's a 798 with the driver. Our target is 698, ready to go except for the driver. So that would just get you a bit under the F1.
So that's 698, so it's carbon chassis, carbon body panels and everything. Then you've got your own engine and gearbox, not your gearbox, I'm guessing.
Well, this gearbox is built for us by Ricardo, completely to our specification. This one's an 8-speed forward, no reverse. We're gonna do a 7-speed with reverse going forward. Yeah. It's got a printed titanium case, and it's got internals, sort of like, in fact, Le Mans style internals to deal with the engine torque. Yeah. But a completely custom designed by Ricardo.
Yeah. And you're doing your own 3D printing on site as well, aren't you?
Yeah.
It's a hell of an investment.
Yeah.
It really is. It's amazing. And you just don't expect it. You're used to these things coming from big companies and stuff, but you're putting an enormous amount of investment in down here.
Yeah, I know, but I mean, look, I'm 71 years old. I've always wanted to do it. I managed to make the money to be able to do it, so I'm going to do it.
Yeah.
I mean, I'm not going to be able to take it with me. I don't have any kids, so there it goes.
Amazing. So yeah, let's come a bit further back. So that, I'm guessing, that's the exhaust valve from the turbos.
Well, that's the entire exhaust.
Oh, it's the entire exhaust.
Originally, we were going to take it out here, but we had a few issues, and we ended up doing it out there. We probably will move back to this position. The hope is that we can make it out of titanium. Yeah. Obviously, you've got an issue with titanium because of the heat, but with it being in the airstream, I think it'll probably cope. Yeah. And titanium's much lighter than Inconel, so it's a weight saver.
So look, just looking down the side of the car, obviously you're venting air out behind the front wheels there, so you're trying to get rid of the air there. But you've got intakes here. But there's a slot right down the bottom there. Is this part of it? Is this all part of the aero package?
Yeah, the slot feeds air into the back of the floor and just improves the floor flow. And on the CFD, we got a massive increase in the operation of the floor with it. So yeah.
And so downforce, you were saying this is 4,000 kilos or whatever. What sort of lap times, what sort of performance do you think that's going to be giving you?
Well, on the version 2 car, we've run through simulation software that we use at the race team in the UK.
Yep.
And with 1,500 horsepower and the same weight as a current F1 car, it shows the car 7 seconds a lap quicker around Albert Park than an RB20.
Really?
Yeah, I know, it's
an
amazing.
RB20 Formula 1 car. I mean, 1,500 horsepower gives you a lot of straight line shunt, doesn't it?
Yeah, I mean, it makes a massive... I mean, look, it's unfair on the F1 guys because obviously they're all running around with a hands tied behind their back, but that's just the reality of the situation, and we just want to show that, you know, other things are possible.
Obviously single-seater. Can we have a look inside the cockpit?
Yeah, sure.
How does it open?
Yeah, well, that's a good question. I think it's round the back here.
Oh, is it on that pull? Oh, look at that.
Steering wheel's titanium, and the column, and we have air conditioning as well. Because
that was going to be my next question. It's going to get hot in there under that canopy, isn't it?
If you shut the canopy and the sun is out, you can get up to 50 degrees here in 5 or 10 minutes.
Yeah.
Honestly, you couldn't drive the car without the air. And the other beauty is, of course, once you've got that, it's actually going to be comfortable.
Yeah.
And that's important.
Is it all right if I ever sit in?
Yeah, no, go ahead.
Right, I'm going to have to take my...
You're not going to find that seat very comfortable. It's hard carbon, but anyway.
Right, okay, let's give it a go. Haven't got my small race boots on today. What have we got going on? You've got a DRS button on here, so you've got an active rear wing, obviously.
Yeah, we can have it. I'm not sure if we'll end up actually having it in the production car because it doesn't make that much difference, and you're going to have weight and complications. So that one's a 50-50.
Fine, okay. And you've got a lot of mechanical adjustments you can do here. So brake bias, different settings as well.
We have ABS.
Yep.
And we also have automatic upshifts, and you can set which gear you start the automatic upshifts in.
Okay.
Because you don't need it when you get to 4th or 5th.
Yeah.
But we need to make the car drivable, and things like ABS and automatic upshifts help you a lot because, you know, the engine speed comes up so quickly that it's very difficult without those sort of things.
Yeah. And what are you going to be running? So you've got 3 screens in front of me here. What are you going to be running on those? Just all the technical information and stuff?
We probably put a bit of a camera view on each one on the side so you can look out the back.
Yeah, just in case anyone's there.
Yeah.
Excellent. Right, let me just jump back out. Amazing. Right, I want to come around the back because you've got a lot of surface area here, isn't it? And I think when you see the car from the side, it looks quite heavy, so quite like a Batmobile, really, isn't it?
You need the fins to balance the cockpit visually. If you just have a cockpit in the middle and it's flat, it's ugly. It doesn't look right. That's the main reason for the curves in the fenders is the Italians that say it's just optical.
Yeah.
But obviously the fin does have some advantages aerodynamically.
Yeah, because if anything, it's almost like there's a riff on it. It's like an old land speed record car. It's got, because these fins, the pods, are as big as the central pod in itself.
Yeah, they're much lighter though.
Yeah, a lot lighter. Yeah. And then you've got this enormous twin plane rear wing, and a rear diffuser, which finishes obviously quite a bit earlier at the moment. Is that design going to change?
On the version 2 car, we've got a lot more out of the floor than we have on this car.
Yeah.
We've got some massive gains there. We're moving the lower control arms up in line with the drive shaft.
Yep.
So they won't be in the airstream anymore, they'll be above. And that's a massive gain as well.
And just looking down there, are those 3D printed wheel hubs you've got as well?
Yeah.
And the suspension arms, the suspension arm ends as well.
The ends are 3D printed titanium and titanium printed uprights. So, I mean, titanium's a fundamentally better metal than aluminium, so we want to use it wherever we can, really.
And what's the plan with the car? Are you hoping to go into production with it?
Yeah, we'd like to. You know, we'd sort of. I figure we try and build 30 cars and sell 27 of them. You're going to need a prototype. I'm going to at least want to keep one, and there'll probably be something that gets screwed up. So, but yeah, we would like to. I mean, look, we see this car as a competitor to the RB17.
Yeah.
And so, you know, we're gonna go after that.
Fantastic. And you're there ahead of them at the moment.
Yeah, well, you know, obviously they got a massive amount of resource and all the other stuff, so I don't know how that's going to pan out, but, you know, it's good to have a target and we just give it a shot.
Great, fantastic. Right, do you think we can start it up and have a listen?
Yeah, sure.
Brilliant. The F-Zero is easily one of the wildest prototypes we've ever encountered, and a question remains about whether wealthy enthusiasts share Dicker's passion and desire for a car that, like the McMurtry Spearling, is so head-scramblingly fast that it can rival F1 lap times. But let's worry about that when the time comes. Right now it looks like Red Bull and Adrian Newey might not have everything their own way.